Good afternoon, everyone, and welcome to today's ASA Abloy Academy virtual instructor-led training on hardware applications specifically for hospital type facilities. My name is Katie Flower. I will be your lead instructor, not just for today, but the entire 8-part series. This is a series and each course is being recorded in case you miss a particular day because of timing. You can always, within a few hours after this session, the recording will be on the ASA Abloy Academy website for you to review and catch up if you happen to miss one or multiple so that you can stay caught up. In addition, within 24 hours, you will receive an email thanking you for your attendance. You can use this as proof of attending for 1 credit hour to use to self-report for continuing education if you need to do so. We have plenty of virtual instructor-led training on ASA Abloy Academy, but also you will find some online courses covering all different types of topics. And if ever there's a topic that you haven't seen or you haven't seen in a while, please feel free to email any one of us and make a suggestion for content. We're always looking to add new content as well. Today's introduction, we will review plans and specifications and what types of things that you would be looking for when it comes to hospital hardware. There is a difference between a specification hardware set as well as a detailed hardware set. I will point out the differences between the two and why they're different. And then we'll get into just an overview of common hardware that's used for hospitals. Not a very in-depth at all, but it will refresh your memory on the different types of hinges and locks and just the real focus on specifically what you're looking to achieve when it comes to hospital hardware. On a set of plans, there's all kinds of information that you can find to select or detail the appropriate hardware. Things like handing, for example, help you not just select what side is the egress side, which side is the lock side, the secure side. Some rooms are very obvious. Here, the corridor is the secure side. The key would be on this side, and the holding side is the egress side. But when it comes to doors and corridors, when you have a double egress pair like this particular one, then you have egress from both directions. And locking the door from the egress side, tomorrow's class covers all the different code requirements that you'll be looking at and some that are specific exceptions for hospitals. But corridor doors, you really have to pay attention to because the egress side can be in both directions. And what else is around you? What is the path of egress to get you to an exit stair or get you to a horizontal exit? Or if you're on the first floor, where are the exits that get you out of the building? Other things you're looking for, wall types. The wall types will indicate the thickness of the wall for your frames, your fire ratings, smoke ratings, acoustic ratings. You may have some areas that you have acoustic insulation for sound, lead lining in x-ray rooms and similar. What is the thickness of the lead? What is the detail of the wall? Bullet resistant, possibly, if you have any kind of detention area within the hospital, which if it's an inner city type hospital, you probably will have something like that. You're looking for tornado shelters and things like that. And then continuity. I like to color my plans, even when I'm doing a takeoff, to just make sure that all of the doors within that fire rated partition are in fact listed as fire rated on the door schedule and vice versa. And if I'm selecting hardware, if I'm writing a specification, a lot of times when you get the door schedule, the fire ratings haven't been put on there yet, and it's always good to cross-check it with the floor plan. The general notes and legend. Every architectural firm will have a legend of some sort. Their symbols may vary from firm to firm, but they'll tell you this symbol designates a wall that has sound attenuation, and this one, there is no sound attenuation. You may have lead line, and with the letter L indicating lead, and then there may be an additional place that indicates the thickness of the lead. Typical fire rated partitions, you may have one single dash for a 1 hour wall and a double dash if it's a 2 hour wall, things like that. You're looking at what does this firm use for their wall types so that you can determine all of those items. The door schedule itself may or may not at the time that you receive it. If you're bidding it, by the time you bid it, there should be hardware sets listed. But if you're writing the specification, this column will be blank. But the information that you're looking for on the door schedule is the location of the door number, the size of the door, the width and the height can affect the hardware. The door elevation, is it a solid flush wood door? Is it a metal door, fiberglass, aluminum? What type of material and what type of elevation? Is there any glass in the door? Does that glass possibly interfere with an exit device or a lock set? And what is the style and rail dimensions? Do you possibly need drop plates on door closers? Items like that that you're paying attention to. The thickness of the door, as well as the frame type. Is it a side light frame? Does the frame have a transom panel? Or what is different about that frame? Is it three-sided? Does it have hospital stops on it, which are terminated 4 to 6 inches above the finished floor for ease of cleaning? And then potentially notes, card reader, exit only, hold open, power operated, lead line, rescue hardware, all those kinds of notes you might find in the comments column. And then sometimes they'll even have a listing of what each of these notes means. The specification itself, this is part 2, which talks about the different manufacturers. When it comes to a hospital, most facilities already have in mind what grade that they want for hardware, maybe even what brands that they want. Maybe they've got an existing facility and they know that they want 3 different brands and that's it. In this particular project, the 3 brands were Corbin, Russwin, Sargent, and Schlage, and it lists the different series numbers so that you know what is considered equal to each other. And if you're doing a takeoff and you're pricing this, you know the series, you'll be able to find out the trim, the keying information, all of this information. If you're writing the specification, you will meet with the owner many times through meetings with the architect to agree upon a basis of design. One of these locks will be in the hardware set itself, and the other 2 will be accepted equals. You may find that they only want one brand, and no substitution. That really is facility dependent. And as I mentioned, you will include the owner in meetings with the architect if you're writing the specification and selecting the hardware. The difference between a specification hardware set and a detailed hardware set. This is a specification hardware set. It has a hardware set number, and then it will list all of the doors that this hardware set applies to. It doesn't tell you the size of the door. It doesn't tell you the location or the handing of the door. It doesn't give you the degree of opening. It doesn't give you any detailed information about the door. You need to look at the door schedule to find that information. If you're doing a takeoff, however, this is the quantity per opening. So 1 electric hinge, 2 heavyweight hinges. They're both the same model number except for the QC has an XX. A specification hardware set will typically not give you the number of wires. It won't give you, you look at the kick plate, it's 10 inches by 2 inch LDW. LDW stands for less door width. So I can have in this hardware set, some of these doors can be 3'6", some of these doors can be 3'8", some of them may be 3'10", and others may be 4 feet wide. but they can all have the same hardware because they've got heavyweight 5-inch tall hinges, and then you provide the details when you submit it for approval in a detailed hardware set. But you have enough information to bid this. So the kick plate that's 10 inch high by 2-inch less door width, if you've got multiple doors that are different widths, then you're going to have to figure out the quantity. I've got 3 that are 3'6", and therefore my kick plate is this wide. I've got 2 that are 3'8", and so my kick plates are this wide, and then the remaining are 48-inch, and I'd have 46-inch wide kick plates. The wall stops show a 406/409, and both of those are the same price, but one is a convex and one is a concave, and the anchoring may be different that goes into the wall. Those types of things would be detailed in the detailed hardware set, but they're not going to be detailed in the specification set. The gasketing gives you the model number, but then you have to determine the width times the height. And again, because you may have multiple doors, you could have 100 doors in this one hardware set. Not all of them are the same size. Some of these may be 7 foot tall and some may be 7'2". So the gasketing size will vary. And if you do have questions, feel free to type them in for the Q&A. I will take a look from time to time to see and make sure. The question I have now is, hospital tips should be recommended. If yes, which code allows this to do? There is no code on hospital tips. When we get into the hinges, I will talk about that and certain openings, but hospital tips are recommended in areas either in behavioral health or if you have a highly clean area. And we'll talk about that not just today, but when we get to the actual doors. We've got 3 openings per session starting on the third one. We actually take a look at some singles and some pairs of doors, and we'll get into where you would use hospital tips. But if you did use them, it would be a prefix to the model number of the hinge. It would be located here. So the specification set gives you enough information, generic enough so that it doesn't pigeonhole you for the size. You can have many doors with the same hardware set. And then the detailed hardware set actually looks like this. It has, we noticed that we had hardware set 234 and we had 6 doors. But when we look at the detailed hardware set, this is hardware set 234.02. The doors are 3'8" wide by 7 foot, and they're hollow metal doors by hollow metal frames, 1 3/4 thick with a narrow light. This gives the exact door number and the location, the handing, the degree of opening, and then the full quantity of hardware based on the number of doors in this hardware set. You can see that now instead of saying QCXX, it's a QC6. They only need 6 wires for this particular lock and the features of this lock in order for it to work. They've detailed the kick plates 10-inch by 42-inch, which is based on 2-inch less door width, and that's how you would show it. They went with the 406 wall stop instead of the 409. There were a couple of corrections that needed to be made. Always make sure if you're detailing a project that has electrified hardware, you'll notice that there is a description of operation in the specification set. That description or operations narrative should also be in the detailed hardware set, whether it's abbreviated or spelled out even more. But during your coordination meeting with electrical and security, you need to know, is this fail-safe or fail-secure? Does it need to be tied into the fire alarm to meet building codes? Do we have free egress at all times? All of those items are important and they must be detailed. Now, I just want to make sure to point out that the Door and Hardware Institute, we will follow, and we do follow, DHI's format: hang the door, secure the door, control the door, protect the door. We follow that format, but a specification hardware set does not go into the same amount of detail as a DHI for your certification. The hardware applications and selecting hardware and the thought process behind it will help you if you are wanting to take your DHI credentials and go through that process. But just so that you know, we're not teaching the DHI style of keeping all of the fasteners and everything for each line item. They get into a lot more detail, and that's because they want to make sure, in order to grant you your certification, that you're familiar enough with not just hardware applications, but all of the detail that goes into a full, complete order. Now, from this detailed hardware set, once it's approved, somebody could physically just take and make the corrections and then order this quantity of hinges without asking anybody else for any further information. Everything on here should be able to be turned into a detailed hardware order. The only exception would be the permanent interchangeable core cylinders, and that you need keying information after the hardware sets are approved, after the submittals are approved. Then you typically have a key meeting, or in the case of a large hospital facility, you may have multiple keying meetings to make sure that you have people from all the different departments giving input. Once the key schedule is approved, then you would have enough information to order the permanent keyed cores. Let's take a look at the factors for selection of hardware for a hospital. There are many factors that are involved. First of all, location. Is it an exterior door? Exterior doors come with a higher security application than most interior doors. Interior wet conditions. If it's any kind of wet atmosphere, then you're going to want to use stainless steel for the hinges and the locks, or at the very least for the hinges. Rated walls for fire rating, that will help you focus on steel or stainless steel for your base materials. Lead line walls would indicate to me that the door is going to be very heavy, and I would probably want to use pivots, but the location of where the door is located is critical in helping select the different types of hardware. Operating rooms and other special function rooms, you have to look at the flow of traffic and where are they bringing the patients in from? Are they bringing them in wheelchairs or in beds? How are they transporting them? Where is the nearest staff elevator, and where is the path to get to those rooms, so that you can, again, look at it and select the appropriate hardware. Door details like the width, it affects the hinge size, the height. The wider the door, the taller the hinge. Exit device size, closer size, and even closer type are affected by the width, and accessories like smoke seal and possibly even weather stripping. The height of the door affects hinge quantity if you're using butt hinges. When you get for fire rated doors, which helps also make the same standard for non-fire rated doors, when it comes to hinge quantity, you use 3 hinges for doors up to 90 inches in height, and 1 additional hinge for any 30 inches or fraction thereof. And you can easily assess how many hinges you need with that formula based on the height of the door. Exit device size, if you're using vertical rods, closer size, and accessories are also affected by the height. The weight of the door affects your hinge selection, and also whether you use continuous hinges or pivots, and your closer size. Your thickness affects all your hardware decisions. Sometimes you will have doors that are thicker than 1 3/4 inches. I don't really often see anything that's going to be less than 1 3/4 inches in a hospital. The swing of the door, in-swing versus out-swing. In-swing affects the lock choice, the closer mounting, overhead stops, and if you can use them and where. Out-swing doors, the hinge pins, whether you need things like non-removable pins, your lock sets, exit devices, closer mounting, overhead stops. If the door swings out onto a corridor, be careful of an overhead stop We cannot stop that door at 110 degrees. If it swings out into an egress corridor, we have to let it swing 180 degrees. Thresholds and other things like that are affected by whether it's in swing or out swing. Security. Security is a huge factor when it comes to hospitals, and this can apply to both interior and exterior doors. If you have areas like a pharmacy or drug storage areas, you're going to want to make sure you lock them up. Access control is a big thing in hospitals because not only do you get the extra security and the audit trail capabilities where you can find out who has been in a room at any given time if anything goes missing or anything happens, but additionally, you can reprogram if you have staff changes, and doctors and staff do not like to carry keys. They'll have a badge that they wear either on their pocket or around their neck, and they'll use that instead of keys. There is always going to be physical keying in a hospital. And when you have access control, you do, for the most part, want key override. So if you need to get in there, you still can. The fire department usually will want a grandmaster key or some high-level key to be able to get into all the openings if there is a fire and they need to get anywhere within the building. So security affects hinges, locks, closers, accessories, all of your decisions. Cleanliness is another big one for hospitals, and more nowadays than ever because of COVID. But cleanliness is an important factor in hospitals. Hospital tip hinges are easier to clean than a regular button tip hinge, but not all areas of the hospital need it. Hands-free pulls. No strikes into the floor for flush bolts or bottom rod exit devices. And by not having strikes in the floor, that is not only for cleanliness, but also just creates so that you don't have any tripping hazards on the floor. Hospital stops on frames. This is a hospital stop. It makes it very easy to clean, whether you're mopping or sweeping or vacuuming or whatever. This is 4 inches, 6 inches above the finished floor. The terminated stop in this case is 45 degrees, but you could have a 90 degrees. You can still get these in fire-rated frames and use them on fire-rated openings. The maximum height would be whatever the door manufacturer tells you. It's either 4 or 6 inches. Stainless steel is very easy to clean. The hardware is, depending on the type, may be a little bit more expensive, but it's going to make it more durable and easier to clean. Automatic operators, mount them on the outside of operating rooms or other clean type rooms so that you don't have dust gathering on the top of the power operator. Antimicrobial finish on hardware helps cut down on bacteria and the spread of bacteria. It doesn't allow it to live on the surfaces. And wave buttons for power operators. Instead of touching the button, just hold your hand close, and that way it helps with the cleanliness as well. Hardware for hospitals needs to be durable and reliable. A hospital is not going anywhere. It's going to be there for 50, 60, 70 years, and they will maintain it, but having to shut down an operating room and build a plastic bubble around the area to work on a door and hardware is problematic for hospitals. Not only does it take extra time and money, but it reduces the facility's capabilities. So hardware that is selected for use in a hospital needs to be heavy duty, durable, and reliable for a long period of time. You want to look for hardware that's been tested well above and beyond the ANSI BHMA cycle testing and verified by a third party. Don't just take the manufacturer's word for it. Ask for third-party certification that if they say they've got an exit device that goes 50 million cycles, have them prove it. Where's the documentation? And it's okay to write that into a specification as well. If the ANSI grade 1 standard is 1 million cycles, but you know that this hospital, you really want a minimum of 6 million cycles, you can write that in the specification. Just make sure that the manufacturers that you're selecting or that the owner is selecting all can meet that criteria. You don't want to play games and have two of the manufacturers able to do it and two other ones are kept out because they can't do it. If you list them in a specification, they should all be able to. It may be an upcharge for them to get there, but all of the manufacturers that are listed should be able to have the criteria that you're looking for. Aesthetics, you wouldn't think that aesthetics plays a big role, but it does play a large part in the selection of hardware for continuity of design on your locks and your exit devices, as well as pull handles and even hinges. Certain areas of the hospital, you may have a chapel, you may have an office area or a really nice meeting room space, but also the patient rooms. Evidence-based design shows us that if you have a patient and they're in an institutional looking patient bedroom, they're not going to heal as fast as if that bedroom feels more like a bedroom that they would have at their house or even at a hotel. And so aesthetic design can help patients heal faster, and then you can serve more patients. ASA ABLOY has a bunch of different continuums, security continuum, and different continuums for all different types of products, which is nice because you can control the cost. You can find a budget-friendly solution along the continuum based on the features that are required and get it at the right price point. So you don't need to necessarily, if you've got access control, you don't need full hardwired access control on every single opening necessarily. You may be able to do it with a standalone lock. Significant cost savings, but yet you're still going to use the same durable, heavy-duty hardware that you've been using. You're just going to have different features. And of course, codes and standards, they drive many of the decisions on what we use for locking, latching, closing, our smoke seals, and other accessories. And not only to meet ICC, which is the International Code Council, they made the International Building Code, and ANSI A117.1, which is the standard for accessibility to meet ADA, NFPA 101, the Life Safety Code, and NFPA 80, the standard for fire doors and hardware. All of these are used for sure, but not just on egress and fire and accessible openings. They've become the standard for all opening types, unless by some kind of exception. So if you have a lever handle that you're using because of ADA, chances are for continuity of design, you'll use lever handles throughout the entire building, and you're going to want to use the same lever handle design on your locks and your exit devices and potentially on pull handles. But the number one factor for selecting hardware on a hospital is the frequency of use. Every hinge manufacturer has a frequency of use chart on their website or in their catalog. You can use this to estimate how many times a year that an opening could be used. The frequency of which a door will be open and closed on a daily, monthly, or yearly basis is the number one factor for selecting hardware, as it speaks to the overall durability level required for those openings. And in order to stay within budget, we don't have a one size fits all. We don't want to just put everything humanly possible on a door opening to make it super heavy duty. If it doesn't require that, save a little bit of money, make sure that you're putting the appropriate grade on that type of door so that you can spend a little bit more on your lead lined or your operating rooms or other doors of higher frequency and that are heavier. Now we'll quickly review the different types of hanging the door. The most common method is commercial butt hinges, but continuous hinges and pivots are also very prevalent in a hospital. Commercial butt hinges, McKinney manufactures to ANSI standards, ANSI BHMA A156.7. A template hinge will fit in any manufacturer's door and frame. It makes it very easy. Whether you've got standard weight hinges or heavyweight hinges, 4.5 inches high or 5 inches high, they will fit in a manufacturer's standard prep. And a good majority of the doors within a hospital facility will be commercial butt hinges. Here are some of the pros and cons. It's a standard prep in the door and frame. That's a good thing. Butt hinges are relatively inexpensive overall to the cost of the opening. They're typically in stock or standard order. You can get them rather quickly. You have many aesthetic options, including the tips, button tips, or hospital tips, a variety of applications, swing clear hinges, wide throw hinges, a variety of options, non-removable pins, and electric through wires for any type of opening that has access control, and a variety of base metals, steel for your fire rated doors, non-ferrous for your exterior, brass or bronze base metal. And if you have an area that's particularly wet or being hosed down and kept clean, then stainless steel as a base metal is available. Some of the cons of commercial butt hinges: they're really not a solution for high frequency doors that are over 300 pounds. And when you get to some of these doors in hospitals, they're a lot wider than most facilities. And that's partly code driven. Doors are typically going to be 3'8" to 4 foot wide per leaf. And the higher the frequency, the heavier the door, then you want to start to look at other solutions besides commercial butt hinges. The top hinge is vulnerable to wear and tear and sag. Every time you open the door, gravity wants to pull that door down and out of the opening. So that top hinge takes a beating. If you have a door that is wide and heavy, then you probably want to look at something besides a butt hinge. And they are subject to vandalism on outswing doors because there is a small gap between the door and the frame as compared to continuous hinges that fill that gap. They're the full height of the door. Assa Abloy has Pemko and Markar continuous hinges. Pemko are the geared type, most commonly aluminum, and Markar is the pin and barrel type. They have steel and stainless steel available. They are built to ANSI BHMA standards, and the grade 1 is going to be the heavy duty, the highest classification, which is 150, grade 1, 150 is 2.5 million cycles, all the way down to grade 3, which is 100,000 cycles. More often than not, you're only going to use grade 1 continuous hinges on a hospital. They also make specialty hinges for behavioral health, and there is no real standard at this time for behavioral health, although the New York State Office of Mental Health has created a set of guidelines and standards that people are starting to recognize and use as the basis of design. The Pemko double-acting hinge and the Markar double-acting hinge can be used for rescue hardware or for doors for patient rooms where you don't want the patient to barricade themselves in and make it hard for you to go in and get in the opening itself. They have the emergency stop, which can be used with the Allen key. I have a short video to show how this works. Pros and cons of continuous hinges: they can carry heavy doors up to 780 pounds. They distribute the weight of the door evenly over the height, increase security because there is no gap between the door and the frame, and reduce vandalism because of that. You don't need any additional reinforcement in the frame. There are 3 grades available, although for most hospitals, you'll only use the grade 1, and they are good for high-frequency doors. Disadvantage or con, it is a non-standard prep in the door and frame. Instead of, some people say either oversize the frame head or undersize the door. Unless the contractor tells you they want the frame oversized, that changes the rough opening. It's better to undersize the door when you're dealing with continuous hinges. They are a higher cost, but again, cost is relative to longevity, so that may not be a big deterrent. There is no vertical adjustment, and it takes a longer installation time. Pivots are the 3rd way that we can hang doors, and you'll see pivot sets used throughout hospitals. Rixson is the osabloid manufacturer that makes pivots which conform to ANSI BHMA, and a grade 1 pivot requires a minimum of 500,000 cycles. Some of the pros, they're great for carrying heavy doors up to 2,000 pounds, and depending on your configuration, you could also send Rixson a note with the design and show them exactly what you need. They may be able to engineer something that will work for you. So even if the door is 2,500 pounds, don't say no until you check with the factory and the technical department. Pivots distribute the weight of the door onto the floor, so they are not load bearing on the frame, and that is a big pro. They're used for high frequency openings and custom applications. They can be used with floor closers, and floor closers can be different thicknesses. Lots of details if you're using pivots to take a look at. Some of the cons, it is a non-standard prep in the door and frame and possibly also the floor. They do cost more money, but again, they will last forever. It does take longer to install, but once they're installed properly, they work very well with very little adjustment for the lifetime. So the first thing we do is hang the door. The second thing would be secure the door. The methods for securing a door are going to be cylindrical locks, mortise locks, and exit devices. We'll take a look at each very briefly. Auxiliary locks, like the hospital latch, are typically used in any push-pull type door, but where you want the door to latch. They're called hospital latches. They can be with cylindrical or mortise. If it's cylindrical, then it's typically a 5-inch back set. If it's a mortise lock, it's going to be a 2 3/4-inch back set. But you can use your elbow or the crook of your arm to pull or push this door open. If you're carrying a tray of food, or you're wheeling a cart with medicine on it, then you can easily get in and out of this door. If you have a mortise lock, then you can have locking functions. The paddles are oriented many different ways. In this case, it's up, but you can also go down with the paddle or sideways. And depending on the manufacturer, these can be handed or non-handed. Use them in patient bedrooms and exam rooms and any place where it's push-pull type operation, but with a latch. And they can go on fire-rated doors as well. Pros and cons of cylindrical locks. They do fit a standard prep in the door. They are available in 3 grades, 1, 2, and 3, 1 being the best. Very easy installation and lower cost. Some of the cons, they're harder to repair. If this gets torqued and the spindle gets twisted, then you pretty much have to throw it away and buy a new lock. Keying limitations, because of the shape of the conventional core, you may be limited to just that manufacturer's keyways. Fewer lever designs, fewer functions, no deadbolt, and so that's lower security. In hospitals, we do use deadbolt functions. As long as you can retract the deadbolt and the latch bolt together, which in most mortise locks you can, then that is going to give you extra security with one motion free egress. With mortise locks, the pros and cons, and this is going to be more of your hospital facilities will have mortise locks as your basis of design, and you may have some cylindrical or tubular in the hospital latch, or maybe in an office area if they do want to mix and match. But by and large, mortise locks will be the basis of design. You can get them in ANSI and security grade 1 depending on the type of cylinder and the manufacturer. There are many mechanical functions, and there's more electrical functions and more electrical options, like request to exit, latch bolt monitoring, and even some integrated access control. Many different lever designs, almost 50 different lever designs, and you can keep that continuity throughout with your exit device trim. More keying options, because a mortise cylinder can be prepped for interchangeable core, removable core, conventional keying. But if you have a different manufacturer for the keying, you can use their mortise cylinder and just make sure that you have the proper cam on the back to work whatever lock set that manufacturer happens to be. Mortise locks are easy to repair. You can keep spare parts, and your locksmith shop can repair them as necessary, and they have a longer life. More often than not, they have better cycle testing to exceed ANSI grade 1. They're heavier duty and more durable. The cons, the pocket itself is a standard prep in the door, but the face hole preps are going to be different based on the different functions and the manufacturer. It does take a little bit longer for installation, but once it's installed, then it's pretty durable. And it has a slightly higher cost to procure, but cost of ownership is going to be where you really save some money with mortise locks. Exit devices, though they may not be required by code in a hospital, there will be certain areas like double egress doors. They're the best for a pair of double egress doors. And also just a pair of doors, same swing. Exit devices give you the best way to latch each door, and each door independent of each other. Surface vertical rod, less bottom rod. Again, we don't want to have any kind of strikes in the floor, either for tripping purposes, but mainly for cleaning purposes. We don't want to cut a strike into the floor that can gather dust. Hospitals are very clean environments. And exit devices have many electrical functions: delayed egress, alarmed exit devices, electric latch retraction to work with power operators or to work with access control, fail-safe or fail-secure outside trim to work with access control, and all kinds of extra features like request to exit, latch bolt monitoring, and things like that. Controlling the door is third. Hang the door, secure the door, control the door. Surface closers, floor closers, and power operators are all very predominant in hospital facilities. You will choose the right one based on where within the building that you are. So for surface closers, there's several different mounting methods. That's a pro, and a lot of times they come out of the box with more than one mounting method for the push side or pull side of the opening. Easy installation. You can get heavy duty arms available with the different manufacturers depending on the type of application of where it is. They're relatively low cost, many different options, including drop plates and offset arms, offset shoes. It is a standard door and frame prep with minimal reinforcing. Some of the cons: aesthetics. The surface closer can get in the way of other hardware. Thankfully, most doors in a hospital are very wide, but if you've got a surface vertical rod with a mag lock and a parallel arm closer, and you've got a narrow door, you may have an issue and you may need to conceal one or the other. They're less efficient. It affects the spring power on the closer, and they are susceptible to vandalism because people can see them and get to them. Floor closers, you can get them, they're heavy duty. They can have shallow depth available. This in the picture is a full depth. They can be used on heavy, wide, and high frequency doors. They're aesthetic because this is in the floor itself. And there is vertical alignment so that you can adjust the height as needed. It is a more difficult installation. It does take a non-standard door and frame prep. They are higher cost, but again, that cost is all relative. I've seen floor closers last 50, 60 years with very minimal maintenance. And so it really depends on your overall budget on construction versus maintenance budget. They're harder to adjust if incorrect threshold is used, but that is a detail that you should look at when you're specifying. Do you have a floor plate or do you have a threshold? And if you have a threshold, pay particular attention to the type that's required by that floor closer. And there is more coordination with other items. Your templating on your hinges may change, or if you're using pivots and things like exit devices, you may need to change and take a look at your templating. Power operators, both of these types are used in hospitals. High energy operators are typically not supplied by your door hardware distributor. Those come installed by companies that are specialized in high energy operator. Low energy operators made by Norton or Sargent, for example, they also have their place in different opening types in a hospital, and those would be in the door hardware package. You may have a combination of both throughout the facility. Some of the typical differences: high energy operators comply with ANSI BHMA A156.10. They are designed to operate quickly and continuously. They're activated by motion sensors. They do require safety sensors and other provisions for safety because the door flies open quicker and it's a non-knowing act. That motion sensor is going to trigger that door to fly open, and the safety sensor will make sure that the door doesn't hit somebody that may be on the other side. They're great for high traffic areas such as emergency rooms. They typically do not interface with access control devices. The low energy operators comply with ANSI BHMA A156.19, and they must operate slowly with minimum force upon impact or resistance. In fact, they have a built-in obstruction detection, and after trying to move the door open, after 3 tries with very minimal force, it'll reverse direction and close, or reverse direction and open the rest of the way. They do take a knowing act to operate. So whether it's a press wall switch or a wave switch where you put your hand close and hold it close, or you have to use a fob, that's a knowing act to operate. They don't just open as you walk up to them. You've got to be able to press on a switch or do something. They do not require additional safety sensors because of this. And they range from low to high traffic areas. So you can use these in high traffic. They can be integrated with access control devices. In fact, many of Norton's power operators that are used in hospitals have onboard built-in power supplies that can power your accessories, like either an electric strike or a maglock or an electric latch retraction exit device, provided that it doesn't have the large inrush. It has to be a motor-driven, like the Sargent 56 or the Corbin Russell MELR, the motor-driven electric latch retraction, less than an amp to power. So as a recap, hardware for hospitals, you need to know the location, where within the facility, and how does that affect your hardware decisions. Your door details: width, thickness, height, swing direction, security. Is it high security, medium security, low security? Cleanliness is big in everything that we do in a hospital, including we don't want any cutouts in the floor. Durable and reliable. It has to be something that is easily maintained. Aesthetics is another factor. Cost is a factor, but it's more about balancing the budget and using the appropriate hardware on the heavy duty openings and not being too overkill on the lighter duty openings. Mix and match appropriately for the frequency of use. Codes and standards drive a lot of decisions when it comes to door hardware, and the frequency of use. The number one factor: how often is that door going to be opened and closed on a daily basis? the higher the traffic, the heavier and more durable the hardware needs to be. And at this point, I will give you my email address and open it up to any questions that you may have. Again, this is just an introduction on the hospital hardware application series. Tomorrow, we'll cover the codes that are related to selecting the appropriate hardware. And on day 3, we get into 3 different openings. Each day we progress. We'll take a look at the hardware set and the thought process and selection for hardware for a lot of your common types of doors that you're going to find in a hospital. And then the final class, the 8th class, will be all the different types of openings that we didn't get to address. And if you have any specific openings as we go through this that we haven't addressed, please send me an email and let me know. Can we make sure that in the final class we talk about this type of opening? And it can be whatever you want. Do we have any questions?
At this point, there are no questions, Kate.
Okay, thank you, Russell. So if we don't have any questions, I'll hang around for just a couple more minutes, but I thank you for your attendance and hope to see you tomorrow at part 2, which is the codes course on hospital codes. Have a great day, everybody.